Hello everybody, welcome to another video lesson. Today we're looking at solving linear systems. Okay, we're going to be able to solve these linear systems of equations using our inverse matrices and a new thing called the Kramer's rule. Okay, so let's check this out. All right, if I have a system of equations like you see here, we can write this in a matrix equation, which we've seen before, and that's going to look something like this. Okay, we call this AX equals B, where A is our coefficient matrix, okay? X is our variables and B are our constants, okay? Now we're all in matrix form, okay? Now, if A is invertible, then we can actually solve for our variables, okay? This is X, again, this is our variables, with this equation of inverse of A times B, okay? Inverse A times B is going to be our solution for our variables. So, a quick example solution here. Okay, xy, again, that's our x matrix, is equal to the inverse, okay, this is A inverse, times B, right? Times B. And when I do that, I get 4, 3. So my solution here would be 4, 3. X is 4, y is 3, all right? So we'll get more in depth on this, but first let's look at our Kramer's rule, okay? Kramer's rule says if I have a system of equations like we have here, okay, again, I've got AX equals B. A is our coefficient matrix, X is our variables, and B are our constants, okay? I'm going to go ahead and look at just the system of equations here, and I'm going to solve for X, okay? So to do that, I'm going to multiply the first equation by D and the second equation by negative B, okay? And when I do that, I get this situation here, and I'm adding these together to get rid of Y and solve for X, okay? I'm trying to solve for X right here, okay? So when I solve for X, I end up with this expression here. I've got ED minus FB over AD minus CB, all right? We can see it here and here. When I solve for X, I get this quotient here, okay? Now, hopefully this AD minus CB looks familiar to you. Hopefully that looks like the determinant of A here, okay, which we've seen before. AD minus CB, that's a determinant of a 2x2 matrix, okay? And I'll go ahead and write this out in this notation here, okay, because we're going to be able to use this to kind of visualize this whole Kramer's rule, all right? But what we have on the top here, okay, is pretty close, right? I've got a D and a B, but my C and my A are replaced with some things, okay? So I'm going to call this the determinant of AX, and we'll call this something different a little bit, but for right now we're going to call it AX. Okay, the determinant of AX, that is ED minus FB, well, if I were to write it in this notation, we can see that instead of having an A, now I have an E, and instead of having a C, now I have a B, okay? So really all I'm doing is I'm taking this column and I'm replacing it with E and F. Now keep in mind though that my E and my F are my constants, okay? That's my constants, all right? So we're just replacing the row of my X variables, okay? Because this row, or sorry, not the row, the column, okay? I'm replacing the column of my X terms, all right, with my coefficient terms. Or sorry, with my constant terms. Sorry, I always get those mixed up. Okay, now I'm going to do the same thing, except I'm going to solve for Y this time. Okay, so I multiply by negative C, and I multiply by A on my bottom row. And when I do that, I get Y is equal to AF minus CE over AD minus BC. So again, I've got this determinant of A on the bottom. And now I've got this determinant of, we're going to call it AY. And I'm just calling it that because I solved for Y to get that. And up here I said AX because I solved for X to get this, all right? Okay, so the determinant of AY, if that's AF minus CE, well, now let's take a look at this from our determinant of A, okay? So now I still have my A, but now I have, instead of D, I have F. Right? Instead of a D, we replace that with F, and instead of a B, I've got an E, okay? We replace that there. So we can see, again, looking back at A, I've got my Y column. My Y column is being replaced by my constants, okay, column. My constants column, which is just matrix B. All right, so what our Kramer rule says is that X equals this determinant of matrix A with our X column replaced by our constant matrix. Okay, kind of a mouthful. So the determinant of matrix A with the X column replaced by the constants matrix. All right. Okay, and that's going to be divided by the determinant of A. And then Y is going to be equal to the determinant of matrix A with the Y column replaced by the constants. Okay, so that's what we've got for our Kramer's rule. Now, that's the case in this context. So let's take a look at this in an even more broad context. Okay, I have a square matrix here. Okay, it's important to know that my matrix A, that's an n by n. Okay, so I've got the first element in the first row, second column, all the way down to the first row, nth column. And then I've got first row, first column, second row, first column, third row, first column, all the way down to the nth row, first column. Okay, so it's going to create an n by n square matrix here. Okay, and then again, if this is AX equals B, then this is going to be my X. These are my variables, and then B, these are my constants. Okay. Okay, so let's take a look at, say, A1, okay, or the determinant of matrix A with the first column replaced by the coefficients. All right, so what that looks like is this right here. All right, so instead of 11, 21, 31, all the way down to N1, okay, now I've got my C1, C2, all the way down to C sub n. Okay, so whatever that row is, okay, so this is my first column. So what I'm doing is I'm replacing my first column with the column of my constants. All right. Okay, so that's the case for we'll call it A sub 1, okay, or the determinant of A sub 1. Okay, so if I look at now A sub 2, now my constants just go and replace the second column. Okay, so instead of 12, 21, all the way down, okay, now I've got my constants replacing my second column. Okay, so this subscript here kind of tells us which column is being replaced by our constants. Okay. Okay, so Kramer's rule in the broadest term is just saying that we can solve for each one of our variables, all right, each one of our unknowns, by just taking this quotient of our determinant of A with the first column replaced over A. Again, this is my first, whatever the first unknown is, okay, that's the one that gets the first column replaced. Okay, so keeping in mind that this column represents x1 and this represents our x2 all the way over to my xn. Okay, so really I can see that whatever column I'm working with, that's the one that is being replaced by my constants, and then I take the determinant of that and divide that by the determinant of A, which is just our regular coefficient matrix without any replacements. Okay, so that might be a little bit confusing, but let's take a look at a few examples. Okay, so example 1. Okay, we're going to go back to our inverses. All right, so we're going to use an inverse matrix to solve the system of equations if possible. Okay, so when we do this, I'm going to say AX is equal to B. So I've got my coefficients matrix, my variables, and my constants. Okay, so the solution of this is going to be X equals inverse A over B. Or sorry, inverse A times B. So in order for me to find the inverse of A, I need to find the determinant first. Okay, so determinant is going to be this right here. I've got AD minus CB, right, which we've done before. Okay, so I get a determinant of negative 39. Okay, so A inverse, I know, is the reciprocal of my determinant, okay, times this matrix here, which is just me switching A and D and then changing the signs of C and B. Okay, so that's how we get this matrix right here. Okay, don't get confused. Don't plug in just matrix A. You have to modify A in that way, switching A and D, changing the signs of C and B. Okay, so then I can go through and distribute my negative 1 over 39. and then I multiply that by b. Okay, so when I multiply that by b, I've got my first row, first column times the first row, first column. Okay, and I've got first row, second column times my first row, second row, first column here. Okay, so I've got, and then on my second row here, I've got 7 over 39 times 36 plus 3 over 39 times negative 19. Okay, and when I go through and simplify that out, that gives me a 3 in the first row and a 5 in the second row. So our answer can be written as 3, 5. Okay. All right. So now let's go back to our Kramer's rule. So that was inverse. So now let's take a look at this Kramer's rule. We're going to use Kramer's rule to find the solution of our system of linear equations. Okay. So first I'm going to write it as ax equals b here, and understand again what Kramer's rule says. Okay, I've got the determinant of a with my x row replaced, okay, over the determinant of a. So for both of these, I'm going to need the determinant of a, so let's go ahead and find that. Okay, determinant of a is just AD minus CB. So when I go ahead and plug those values in, so this is AD and CB. Okay, so that's going to give me a determinant of -1. Okay, so now let's take a look. How do I find this determinant of a with the x rows replaced? Okay, all I do is I have my same A, my same A matrix, except now instead of a 2 and a 5, I've got this 4 and -6 here in my first column. Okay, I've replaced my 2 and my 5 with my constants 4 and -6. And then the rest of the matrix stays the same. So now I just do the same thing as far as finding the determinant, AD minus CB, and that's going to give me -18. Okay. All right. Now let's go ahead and find our A with the y's replaced. Okay. So I'm just taking my constants and I'm just shifting them over to the y column. Okay, because this is my x column, this is my y column. Okay, so now I'm shifting them over to the y column, and then my x columns go back to normal. Okay. And now that I've done that, I just do the same process for my determinant. Okay, AD minus CB. So that's going to give us -12 minus 20, and that gives me -32. So my x is going to be the quotient of my -18 and my -1, and my y is going to be the quotient of my -32 and my -1 again. Okay. So we're just replacing these values, or these expressions, with the values that we found. Okay. So when I do that, I get 18, and this should be a positive 32. So I can write my expression, again, that's a positive 32 there. So that is my solution, 18, 32. Okay. All right, let's take a look at another example. Let's see here, I'm going to rewrite this as ax plus b. Okay, again, I've got my Kramer's rule that we're going to use. I didn't put the prompt, but the same prompt using Kramer's rule. Okay, so now first thing we should do is find the determinant of a. Okay, determinant of a, when I do that, I have 12 times 3 minus 4 times 9, which you can see gives us -36 plus 36, which equals 0. And that's an issue. Why? Because Kramer's rule has us dividing by this number right here. Okay, so I have this division by 0, which gives me an indeterminate situation here, undefined rather. Okay, so we have no unique solution for this when I have a determinant of 0. Okay. Okay, last example here, we're going to use Kramer's rule again, except now, now I've got a 3 by 3. Okay, so here is what this tells me for Kramer's rule up here. Okay, these are going to be my solutions. So I need to find the determinant of A. All right, so when I do this, okay, I take a look at my first column, and then my first element, and then I get rid of that column and row that's in, and what I'm left with is this 2 by 2 matrix. That's what I have here. Okay, and that's what I'm finding the determinant of times that -2 that's out in front. Then I move over again in my first row, get rid of that row, get rid of the column that's in, and I have my 3, 2, 1, 0. That's this 2 by 2 determinant that we're going to find. Okay. Then I move on over again to -1, cross out the row, cross out the column. what's left is this 2 by 2, and we find the determinant of that right there times our -1. Okay, so that's the process there. We should have seen that in a previous lesson. And when we start taking our determinants, we get 2 times 6, -2 times 6, minus 4 times -2, plus -1 times -12, which gives us a determinant of 6. Okay, so our determinant of A is equal to 6. So now let's go ahead and find the determinant of A with x's replaced. Okay, so again, all I'm doing is I'm replacing my x column with my constants, okay, -3, 6, and 1. All right, so now when I go ahead and take the determinant of this, you can see every time you see a red element in here, that is one of our replaced values. Okay, so we go through the same process here, cross out our row on our column, and we have our 2 by 2 matrix. I won't go into too much detail about that. Should understand that by now, hopefully. So now I've got -3 times +6 minus 4 times -2 plus -1 times -19, which gives us a determinant with the x column replaced of 9. Okay. Okay, so here's what we know so far. We've got the determinant of A, and we have the determinant of A with x's replaced. So now let's find these last two, determinant of A with y replaced and with z column replaced. Okay, so A with y replaced. Again, this is my y column. So that's why we're doing A with y replaced. Okay, so these are all just my constants. Okay, remember that. These are just my constants. All right, so it was the B matrix when you wrote this as AX equals B. Okay? So I can go through and find our determinant. Okay, make sure you're writing this whole process down just as practice. And I get 1 for my determinant of A with Y replaced. Okay, so now our last thing we have to find is A with Z replaced, determinant of A with Z replaced. So this is my Z column that we're replacing with our constants. And then from there, I go ahead and I find the determinant of this 3 by 3 matrix, which looks like this, and it gives me a value of 4. Okay, so the determinant of A with Z replaced is 4. Okay, so I'm going to go ahead and put the system back up that we're solving for, just so we kind of remember what we're solving for. All right, and all the information that we need. Okay, so with our Kramer's rule, we know that A with X replaced over or the determinant of A with X replaced over the determinant of A is going to be just 9 over 6, and that reduces down to 3 over 2. And then Y is equal to the determinant of A with Y replaced, okay, over the determinant of A, so that's going to be 1 over 6. 1 over 6, there we go, got out of order there. Okay, and then our Z, as we can see, is the determinant of A with Z replaced over the determinant of A, which is 4 over our 6 again, which reduces to 2 over 3. Okay, so our final answer here for solving our solution, or solving our system, is 3 over 2, 1/6, and 2/3. All right, so that's all for this lesson. Good luck, guys, on your practice.